All right, the first law of thermodynamics can be expressed as the equation Q is equal to W plus delta U, where Q is the heat. So the amount of heat, the net amount of heat, is equal to the work plus the change in internal energy. So what we're going to do is we're going to look at when these values are positive, negative, or zero, okay, so that we know what to substitute in. First, we're going to look at heat. Heat is positive if heat is added. It's negative if it's removed. And it could be zero if we have an adiabatic process. Okay? Now, sometimes heat is both added and removed within a process. Okay? And so therefore, we need to find the net amount of heat. So the equation to find the amount of heat that was added or removed is to take the amount of heat that was added and subtract the amount of heat that was removed. Now we use QH for the heat that's added because if you touch something to a hotter reservoir, heat is going to be added to what you touched there. If you touch something to a colder reservoir, heat is going to be removed from what you touched. Okay? So this is how we find the net amount of heat. That being said, some processes are adiabatic, which means no net heat is added or removed. This happens when it is a rapid expansion or compression. So a key word for when it's zero is if it says rapid, okay? Next, let's go ahead and look at the work, okay? If work is done by the gas, then it is positive work. What we mean by this is if the container or whatever, the gas expands, then the work is being done by the gas. So it might say that in the problem. So this is a key word to look for to know that it's positive. Or if you see that the volume increased, so the gas expanded, then you'll know that this is a positive amount of work that was done. Work is negative if work is done on the gas. Okay? This happens when the gas is compressed. So again, you might see in the problem the word work was done on the gas, then you'll know it's negative. Or you might notice that the volume decreased and then it was therefore was compressed, and you'll know that negative work was done as well. Now, work could also be zero. This happens when we have an isochoric or an isovolumetric process. That means the volume does not change. Keywords here would be a rigid container. Okay, so if the gas is in a rigid container, then it's not going to expand or compress. Okay, so there'll be no change in volume, and the work is zero. Lastly, we need to look at the change in internal energy. The change in internal energy is directly proportional to temperature. So we can look at the temperature to figure out whether this change in internal energy was positive or negative. If the temperature increases, that's a positive change in internal energy. If the temperature decreases, it's a negative change in internal energy. If the process is isothermal, remember that means there's no change in temperature, then the change in internal energy is also zero. Okay? However, it doesn't have to be isothermal, it doesn't have to never change at temperature. It could be a cyclic process, okay, in which there's no net change in temperature. So the temperature might go up, then it goes back down, so it ends up where it started, okay? In that case, there's no change in internal energy as well. Keyword here is cyclic.